Well, here's this one. Now, once again, this problem, just like the last problem, I'm gonna split it up into numerators and denominators for this one, okay? So, I'll still have my fraction line, but I'm not even worried right now about my denominator. So once again, if it helps you just to kind of cover that up, do it. So it's not bothering you, it's not causing any extra questions or anxiety here, okay? So from the numerator though, we have bases of x, y's, and z's here. Was x to the power 4, y to the power 3, z to the power 6. I'm going to take this exponent on the outside and multiply it by each of the exponents on the inside. So that's 4 times 7, 3 times 7, and 6 times 7, which will give me new exponents for each of the bases, x, y, and z. So the x now has a power of 4 times 7, which is 28. The y has an exponent 3 times 7 is 21. And z has a power of 6 times 7, which is 42. Now, for me, that's as much as I can simplify that numerator. So now I will want to see that denominator. So let's get rid of that. And let's take a look. Oh, this is nice because the bases are the same, right? You got bases of x, y, and z. And so x to the power of 6, y to the power of 3, z to the power of, that's a 1. Remember, there's a phantom 1 right there. And if it helps you to see that phantom 1, then do it, okay? But I'm going to take the 6 exponent and distribute it into each exponent on the inside. So that's 6 to the power of 6. That's 6 times 6, rather, 3 times 6, and then 1 times 6. This will give me new exponents for each of these bases, x, y, and z. X to the power of 6 times 6, that's 36. Y to the power of 3 times 6 is 18. And z to the power of 1 times 6 is 6, okay? Now, before I continue, we will end up with some negative exponents, but remember, especially if we're looking at a situation like this, it's going to be with the x's, and you can see that there's more x's here in the denominator than the numerator. That means in the end, when I actually do simplify this, I'm going to have some x's in the denominator, okay? So I'm kind of setting that up. Again, I just want you to be able to think about this, not in such robotic terms, but notice this. There's more x's in the denominator than the numerator. Now, for the y's, there's more in the numerator than the denominator, so I'll expect there to be y's in the numerator. The z's as well, there's more z's in the numerator than the denominator, so I'll expect there to be z's in the numerator, like this, okay? So I'm just kind of setting up the answer for those. But I evaluate these one base at a time. So this is all division of the same bases. We'll start with the x's. That means you take the 28 exponent from the numerator, and then you'd subtract the 36 exponent. That's at 28, dang it. There we go. You'd subtract that exponent from the denominator. That then gives me x to the power of, looks like negative 8. Which again would show, like if you saw this on the last section, you just flip that and make it 1 over x to the power of 8. So that's why this is x to the power of 8 and in the denominator for our final answer. Now we look at our base y's. So there was a 21 exponent in the numerator, an 18 exponent in the denominator. We're going to subtract those. Well, that would be y to the power of 21 minus 18. I get 3. Since, again, there's more y's in the numerator, that's y to the power of 3 in the numerator, as we have already set up. And then the z's, finally. We got 42 z's in the numerator, 6 in the denominator. Let's go ahead and subtract those. And that will tell us how many z's we end up with in the numerator, by the way. 42 minus 6, 36. So that's z to the power of 36 in the numerator. That's it. We did it. Now, again, I explained why there's x's here in the denominator, y's and z's in the numerator. I just want you to be able to look at this after it's been simplified, right, from all this distribution stuff into the exponents. Notice that, okay? Are there more of each in the numerator or denominator? That will tell you where they will go in the final simplified expression.